This time we will proceed to the derivative of exponential and logarithmic functions. So this will be our topic today. We have the exponential, that is the derivative of e to the u, which is equivalent to e to the u du. And also the derivative of a to the u equals ln a to the u ln a derivative of u. And in logarithmic functions, we have the derivative of a logarithm of a to the u equals the logarithm of e to the base of a over u du, wherein a is not equal to u. And also, the derivative of this one is the natural logarithm of u, or ln u, is equal to 1 over u du. So this is usually the equation that is being used for a logarithmic function, the derivative of ln u, which is equivalent to 1 over u du. Now, when we use this formula, just a reminder, in the laws of logarithm, ln of mn is equivalent to ln of m plus ln of n. So we have here a multiplication of m and n, so it appears that ln of m plus ln of n. So we make use of positive here. While ln of m over n, that is equivalent to ln of m minus ln of n. So this is the your numerator, and then the denominator. So you have here minus. And then take note also that ln of e raised to x is equivalent to x, because ln of e is equivalent to 1. Actually, this one can be rewrite as, let's say, ln of e raised to x can be rewrite as x ln of e. And then ln of e is equivalent to 1, therefore it is now equals to x. X times 1, that is x. So that is how we use this law of logarithm. Okay, so we have this one is the derivative. These are our formula for finding the derivative of exponential and logarithmic function. So we will now start our example for finding the derivative of exponential and logarithmic functions. So we will start with this example first, this formula. Let's say number 1, y is equivalent to 3e to the 4x, and then its derivative, that is y sub 1, that is y prime, that is equivalent to 3 times e to the 4x. This is 3. We write first this 3 because this is constant, and then we have here e to the u. Derivative of e to the u equals e to the u. We have here our formula times derivative of u. So we will write first our e to the u, that is e to the 4x times the derivative of our u, which is 4x. Okay, so derivative of 4x equals 4 times 3, that is 12. 12, and then this one, we will just copy here, e, that is e raised to 4x. So in other words, for this case, if we take the derivative of 4x, that is equivalent to 4. And that 4 will be multiplied to 3, that becomes 12. So this will be our final answer. Now, another example, let's say y equals 3 to the 4x. This is the derivative of a to the u. This is our a. Take note, if a is our constant, 3 to the 4x, so a to the u. So we will be using this formula. So we have y prime, that is the derivative of a to the u, equals a to the u. So we will just copy a to the u, that is 3 raised to 4x, and then ln of a, so ln of 3 times the derivative of u, the derivative of 4x. This will serve as our u, so the derivative of 4x. So that this is now equivalent to 3 to the 4x ln of 3 derivative of 4x equals 4. So we have here a multiplier. Just write 4 before ln of 3. So we will transfer that. We have 3 raised to 4x. Do not multiply 4 by 3. Instead, you write it first before ln 3. ln of 3. This time, we will make use of this formula. Okay. So that is equivalent to 3 raised to 4x, and then you have your ln of 3 raised to 4. Okay, this 4 will be the exponent of 3. We will make use of this formula. So that 3 raised to 4 equals 3 times 3, 9 times 3, 9 times 9, 81. So we have here 81. This ln of 3 to the 4 is ln of 81. So we will write here 3, we just copy this first, 3 raised to 4x, okay, so I will erase this one, and then 3 raised to 4x, and then you have here ln of 81. ln of 81 is the value for ln of 3 raised to 4. 3 to 4, that is, you have to multiply 3 by 4 times. So 3 times 3 times 3 times 3. So 3 times 3, 9 times 3, 27 times 3, 81. So this is now the result of our derivative y prime to this function. Now we will have an example for this formula. You have number 3, example number 3. We have y is equivalent to 4 logarithm of let's say 5x, okay, 5 raised to x, or 2x. So this is now our a to the u, the logarithm of a to the u, which is equivalent to, if we take the derivative of that one, that is equivalent to 4 logarithm, okay, that is logarithm of e to the base of a. So logarithm of e, you write it here, and then the base of a, our base here is 5, divided by u. Our u here is the exponent, that is 2x. And then the derivative of u, the derivative of 2x times the derivative of 2x. So we have here, I will rewrite here, y prime equals, okay, the derivative of 2x equals, derivative of 2x equals 2. Okay, the result of this one is 2. 2 times 4, that is 8. So we have here 8. The 8 divided by 2, take note, 2 times 4, 8 divided by 2, that is 4. We have here 4 log of e to the base of 5 all over x. So we cancel here 2. Or in other words, 4 divided by 2 equals 2. Times the derivative of 2x equals 2. So 2 times 2, that is 4. This will be our final answer. Example number 3. This time, we will proceed to example number 4. We have number 4. Let's say y is equivalent to 3 ln of 4 minus 6x. So this one is ln of u. ln of u. 3 ln of u. So that when we take the derivative, that is y prime, which is equivalent to 3, derivative of ln u equals 1 over u times the derivative of u. 1 over u, derivative of u. So 1 over our u, that is 4. This is 4 minus 6x times the derivative of 4 minus 6x. So that 3 times 1 equals 3 all over 4 minus 6x. Derivative of 4 minus 6x equals negative 6. So we will multiply negative 6 times 3, that is negative 18. Negative 18 divided by, so this one is 18 divided by 4 minus 6x. So notice this is 18, 4, and 6. They are divisible by 2. So we will divide both sides from your numerator and denominator by 2. So, or we will factor. We have 2 times negative 9, which is equivalent to negative 18, all over 2 times, this is 4, so we have here 2 minus 3x. 2 times 2 equals 4, 2 times 3 equals negative 6x. So we will now cancel 2. These are common. So we have negative 9 all over 2 minus 3x. This is now our derivative of y equals 3 ln 4 minus 3x. Another example for the derivative of exponential and logarithmic function, let's say number 5. Example number 5, we have y is equivalent to 3x e raised to cosine 4x. Notice this is e raised to cosine 4x, and then we have here 3x. This is algebraic functions, and then this one is exponential function. So again, we will make use of we cannot apply directly this formula, but we have to use first our derivative of uv, which is equivalent to u dv plus v du. So we will make use of this formula, so that when we apply that formula, that is y prime is equivalent to, this will be our u, and then this will be our v, so 3x times the derivative of e to the cosine of 4x plus e cosine 4x times the derivative of 3x. So this one is 3x derivative of e cosine 4x, that is e to the u du. So we will just copy this one first. We have e cosine of 4x times the derivative of cosine 4x. This is e to the u du. E to the u du. So we have here. And then the derivative of 3x, we have here, derivative of 3x equals 3. So we will write first 3 before e to the cosine 4x. So we have here 3 e raised to cosine 4x. Now we have 3x e raised to cosine 4x. Derivative of cosine 4x, that is negative sign. Take note, the derivative of cosine 4x equals negative sign. Take note, derivative of cosine u equals negative sine u du. So we will apply this formula for this part. So negative sine of 4x, okay, this one, times du times the derivative of 4x. And then we have to copy this one, that is plus 3e cosine 4x. And then this is negative derivative of 4x equals 4 times negative equals negative 4 times 3, that is 12. So, okay, so I will write here 3x, this one, and then derivative of 4x times negative, that is negative 4. That is negative 12x. So negative 12x e raised to cosine of 4x, and then we copy this one, that is sine of 4x plus 3 e cosine 4x. This will be our final answer. Another example, we have number 6. Okay, number 6. Let's say y is equivalent to 4 raised to 2x plus ln of 5x. Okay, we have here ln of 5x. So this will serve as our ln u. And then this one is 4 to the 2x. This is a to the u. So that when we apply the derivative for this part, you have here y prime, which is equivalent to a to the u, derivative of a to the u equals a to the u ln a du. So 4 to the 2x, you just copy your a to the u. And then ln u, that means ln of our u here is 4. I mean ln a, our a is 4. And then the derivative of u. Derivative of u. So the derivative of 2x. And then plus, this one is ln u. Derivative of ln u equals 1 over u du. 1 over u du. So 1 over u. This will serve as our u ln u. So ln of 5x times the derivative of ln of 5x. ln of 5x. Okay, u du. And then derivative. Okay, derivative of 2x equals 2. So we will write here 2. Okay, we will just copy this one. First we have 4 raised to 2x and then 2 ln of 4. Derivative of 2x equals 2. So we will write here 2 ln of 4 plus derivative of ln of 5x. Oh, I will just copy this one. First we have 1 over ln of 5x. Derivative of ln of 5x equals 1 over 5x times the derivative of 5x. That is 1 over u du. So that this 2 will be the exponent of 4. So 4 raised to 2x ln of 4 squared plus, I will just copy this one first. I will write here 1 over, so I will multiply this one by ln. We have here 5x ln of 5x. Multiply 5x by ln of 5x. So we will just copy this 5x and then ln of 5x. Derivative of 5x equals 5. So if you have noticed here, we have here 5. We have also here 5. So we will cancel that one. Our final answer equals 4 raised to 2x ln of 4 squared. That is ln of 16. ln of 16 plus 1 over x ln of 5x. This will be our final answer.